All right, this is chapter 3, lesson 8, solve systems of equations algebraically. So in the previous lessons, we talked about solving equations graphically using a graph. This way, we're going to actually set up equations and solve them. So when we solve a system algebraically, in the previous lesson, you estimated the solution of a system of equations by graphing. Blank is an algebraic model that can be used to find exact solution of a system of equations. In that blank, you're going to write substitution. Okay. Substitution. Slope, intercept, and standard form. Sometimes one or both equations are written in standard form. When solving a system by substitution, one of the equations should be solved for either x or y. So you want to have y by itself, or you want to have x by itself when you're solving systems algebraically. So let's take a look at two examples. The first example I have is this one. So it says solve the system of equation algebraically. Y equals x minus 3 and y equals 2x. Since y is equal to 2x, you can replace y with 2x in the first equation, okay? So I'm going to go ahead and do that. So when I do that, I have 2x equals x minus 3. I subtract x from both sides, so that gives me x equals negative 3, okay? Then I can plug this back into one of my equations and solve for y. So I'm going to plug it back into y equals 2x. So 2 times negative 3 gives me negative 6. So when y equals negative 3, the solution of the system of equations is negative 3, comma, negative 6. I can check by graphing, and I do get the same solution points. Okay. Second example, I want to make sure you got all that. Yep, graph. Okay. Second example, solve the system of equations algebraically. Y equals 3x plus 8 and 8x plus 4y equals 12. I do have one of my equations solved for y already. So what I'm going to do is I'm going to take that and I'm going to plug it in for the y in my second equation. So I have 8x plus 4y equals 12. Then I'm going to take 8x plus 4 times the quantity 3x plus 8 equals 12. Because in my original problem, that's what it told me that y equaled. Use the distributive property. So I get 8x plus 4 times 3x plus 4 times 8 equals 12, which simplifies to 8x plus 12x plus 32 equals 12. 8x and 12x are like terms, so I can add them together. 8 plus 12 gives me 20, so I have 20x plus 32 equals 12. I subtract 32 from both sides. 20x, so I get 20x equals negative 20. And then I divide both sides by 20, so x equals negative 1. Since x equals negative 1, I can replace x with negative 1 in the equation y equals 3x plus 8 to find the value of y. So when I do that, I get y equals 3 times negative 1 plus 8. 3 times negative 1 is negative 3, plus 8 gives me 5. So the solution of my systems is negative 1, comma 5. Okay, there are a couple of try problems below. Go ahead, pause the video, try them out, and when you're done, we will go over the answers together. All right, now that you've had a chance to try the try-it problems on your own, let's go over the answers together. So letter A says y equals x plus 4 and y equals 2. So I'm just going to go ahead and plug in 2 for y. So I get 2 equals x plus 4. Then I subtract 4 from both sides. I get negative 2 equals x. So x equals negative 2, y equals 2. So my solution is negative 2, 2. For letter B, y equals x minus 6 and y equals 3x. Okay, so I'm going to take the 3x, I'm going to plug it in. 3x equals x minus 6. Subtract x from both sides. I get 2x equals -6. Divide both sides by 2. So I get x equals -3. I'm going to plug that back into my 3 times x. So y equals 3 times -3. So y equals -9. So my solution is -3, -9. Okay. For letter C, y equals 2x plus 1 and 3x plus 4y equals 26. I'm going to take this, I'm going to plug it in for y. So I get 3x plus 4 times 2x plus 1 equals 26. Use the distributive property, so 4 times 2 gives me 8x. 4 times 1 gives me 4. Okay. 3x plus 8x is 11x, plus 4 equals 26. Subtract 4. 11x, 26 minus 4 is 22. Divide by 11, so x equals 2. Then I'm going to plug that back in to my first equation. Y equals 2 times 2 plus 1. So y equals 4 plus 1, y equals 5. Okay, so my system, or my solution, is 2, 5. For letter D, I have 2x plus 5y equals 44. Y equals 6x minus 4. So I'm going to go ahead and plug the second equation into the first. So 2x plus 5 times 6x minus 4 equals 44. I use the distributive property. 5 times 6 is 30x. 5 times 4 is 20. Okay. 2x plus 30x is 32x. Minus 20 equals 44. I add 20 to both sides. 32x equals 64. Divide both sides by 32. So x equals 2. Then I plug it back into my second equation. Y equals 6 times 2 minus 4. So y is 12 minus 4, or y equals 8. So my solution is 2, 8. Okay. You then have this orange foldable over here. Okay. The orange foldable talks about solving systems of linear equations using substitution. So here's the steps, right? How to solve a system of linear equations using substitution. So step 1. Okay. So step 1 is solve one of the equations for one of the variables. Okay, so solve one of the equations for one of the variables. Step 2, substitute the expression into the other equation. Okay. Step 3 is substitute the number you get from step 2. Okay. Into either of the original equations. Either of the original equations. Okay? So step 1, solve one of the equations for one of the variables. Step 2, substitute the expression into the other equation. So whatever you got from step 1, substitute it into the other equation. And step 3 is substitute the number you got during step 2 into either of the original equations. Okay? So some examples. Example 1, y equals 2x plus 5 and 3x plus y equals 10. So as you can see, this is in slope form, this is not, so I need to solve this. So I'm going to subtract 3x from both sides, so I get y equals negative 3x plus 10. Okay, I don't actually have to do that, I can just plug it in, but it's up to you. Okay, so what I'm going to do is I'm going to take this and I'm going to plug it into my equation. So I get 3x plus 2x plus 5 equals 10. I'm going to solve it for x. So I get 5x plus 5 equals 10. Subtract both sides from 5. So 5x equals 5. Divide by 5. X equals 1. I'm going to plug that back into my one of my original equations. Okay, so when I do that, I plug in 1. 2 times 1 is 2, plus 5 is 7. So my solution is 1, 7. Okay. Example number 2. 3x plus 4y equals 8. X equals 16 minus 4y. Okay, so I already have one of these solved for a variable, which is great. I'm going to take that and I'm going to substitute it in for x. So I get 3 times 16 minus 4y plus 4y equals 8. Okay. Use the distributive property. 16 times 3 is 48 minus 12y plus 4y equals 8. So negative 12y plus 4y is negative 8y equals 8. Subtract 48. Negative 8y is negative 40. Divide by negative 8, y equals 5. I'm going to plug that back into my equation. X equals 16 minus 4 times 5. So x equals 16 minus 20. So x is negative 4. So my solution is negative 4, 5. Okay. Example number 3. X plus 4y equals 9 and x minus y equals 4. Neither of these are in where I have one variable on each side. So I'm going to go ahead and solve one of these. I'm going to solve the bottom one. So all I have to do is add y to both sides. So I get x equals 4 plus y. Okay, I'm going to take that. I'm going to plug it into my first equation. So x plus 4y equals 9. So this now becomes 4 plus y plus 4y equals 9. So 4 plus 5y equals 9. Subtract 4. 5y equals 5. Divide by 5. Y equals 1. Okay. I'll plug that back into my equation. X plus 4y equals 9. You don't have to plug it into that equation. It's up to you. So x plus 4 times 1 equals 9. So x plus 4 equals 9. Subtract 4. X equals 5. So my solution is 5, 1. Okay. All right. The other thing I wanted to look at was back on page 71. Remember that blue foldable? Okay. So it had the one solution, no solution, infinitely many solutions. But it also had ways to do it not only graphically, but also using substitution or elimination. So we're going to go ahead and look at how to use substitution in order to solve these and kind of what they look like. Okay, so the first one I have is 2x plus 5y equals 14 and 6x plus 7y equals 10. I'm going to solve one of these for a variable. I'm going to take the first one and solve it for one of my variables. I'm going to solve it for x. Okay, so this means I have subtracted by 5y. So I get 2x equals negative 5y plus 14 divided by 2. X is negative 5/2 y plus 7. So I'm going to take that and I can plug it back into my second equation. So 6 times negative 5 halves y plus 7y equals 10. So this gives me negative 15y plus 42 plus 7y equals 10. Negative 15 plus 7 gives me negative 8. So negative 8y plus 42 equals 10. Subtract 42 from both sides. Negative 8y equals negative 32. Divide by negative 8. So y equals 4. Okay, I can take that and plug it back into any of my original equations. We'll plug it back into the first one. So 2x plus 5 times 4 equals 14. So 2x plus 20 equals 14. Subtract 20 from both sides. 14 minus 20 gives me negative 6. Divide by 2. X equals negative 3. So my solution is negative 3 comma 4. Okay. So that does give me one solution. All right. So then I can look at no solution. Okay. So I have x minus 2y equals 7 and negative x plus 2y equals 7. Okay. So I'm going to go ahead and solve one of these. For x, I'm going to add 2y to this. So I get x equals 7 plus 2y. Okay, then I'm going to go ahead and plug this in for my equation. So negative 7 plus 2y equals 7. So negative 7 minus 2y plus 2y equals 7. So I get negative 7 equals 7. This, negative 7 can never equal 7. So this is a no solution. So anytime you get something on one side of your equation that there's no way that can equal the other thing on the other side, that determines that it's a no solution. Okay. For infinitely many solutions, I have negative 16x plus 2y equals negative 2 and y equals 8x minus 1. One of these is already solved for a variable, so I'm just going to take that and plug it back in. Okay, so negative 16x plus 16x minus 2 equals negative 2. Negative 16x plus 16x cancels. I'm left with negative 2 equals negative 2. That is a true statement. It will always be true, which means that there are infinitely many solutions. Okay, so I get the same thing on both sides of the equation. So I get infinitely many solutions.